Good morning everyone. In the previous video, we saw how to reduce an expression. When a complex expression is there, designing the logic circuit is a difficult task, we saw. Then we simplified that term, the Boolean expression, into simpler form and we designed the logic circuit. Then we found that when a reduced expression is there, the circuit is becoming as much simpler. So we are going to see another method which we can use to reduce the expression. That method is known as Carnot method. Carnot method. Carnot method. Then what is Carnot map? Carnot map is a graphical representation of the fundamental products in a truth table. Okay, Carnot map is a graphical way of representing the fundamental products in a truth table. And this Carnot map is nothing. It is a set of squares which are representing either a min term or a max term. We say Carnot map is a set of squares which are representing either a min term or a max term. Now let us see the different terms as well as the rules behind the Carnot map creation. See, when we have a two variable inputs, for example, we have A as well as B. Two variables are there. In order to reduce this expression, with two variables, we should have a Carnot map with 2 to the power 2 squares. That is 2 to the power n. 2 to the power n. N stands for the number of variables. Okay, so we are going to have a 2 to the power 2 squares. That means when we have A and B, we will make a Carnot map with 4 squares. Okay, one is used for representing the row-wise order and the other variable is used for representing the column-wise order. And we are going to give the numbers to these rows 0, 1 and the columns are also numbered as 0, 1. We are taking A for these rows and B for the columns. Now you have to put the number to these squares. In order to number these squares, we will take out the row coordinator as well as the column coordinator. That is R, C. Row is numbered from 0. Column is numbered with the 0, 0, 0. Row and column 1, 0, 1. This is row is 1, column is 0, row is 1, column is 1. See, take out the decimal equivalent of these binary equivalents. 0, 0 represents a 0. 0, 1 represents 1. 1, 0 represents the decimal number 2. 1, 1 represents the decimal number 3. So these squares are numbered as 0, 1, 2, 3. Okay. Now, if they are representing the SOP expression, these all squares must be representing min terms. Okay, I told you the Carnot map is a set of squares which are representing either a min term or a max term. And if we are going to represent this Carnot map for the reduction of SOP expression, then these squares will be representing the min times. That is, this particular square is representing min times 0, min time 1, min time 2, min time 3, etc. And if this Carnot map is representing the product of sums, then these squares will be representing the max times. Max time 0, max time 1, max time 2, max time 3. That means the square, what value the square contains. That means what does the Carnot map represent will be depending on the expression what we are selecting, whether it is a canonical SOP or a canonical POS. That means the Carnot map what we are having will be depending upon the expression, whether it is SOP or POS. I think you understood it. That means for a two variable expression, we need to have a 2 to the power n number of squares. And the n stands for what? N stands for the number of variables in that expression. Suppose we have two variables in this expression, then 2 to the power 2, 4 number of squares are there, as I said. Okay, now we are going to see an expression which is having 3 variables. Then we will see how many squares are required for that particular expression. Okay. See, when 3 variables are there, A, B, C. 2 to the power 3. As I said, 2 to the power n. N stands for the number of variables. Here n is 3. So 2 to the power 3. 8 squares will be there in that particular Carnot map. So we can draw it. Two rows and 4 columns. Okay, then we will put first variable A for these row coordinators and then B and C for the column coordinators. This side we will take B and C. Okay, now you see we are putting A with 0, row number 0 and the row number 1, column number 0, 0, 0, 1, 1, 1 and 1, 0. You can see this numbering is not following the binary progression. Why it is so, that I will tell you soon. Okay, now you can see we are putting the row coordinator and the column coordinator. Row is 0, column is 0, 0, row 0, 0, 1, 0, 1, 1, 0, 1, 0. This is 1, 0, 0 and this is 1, 0, 1. This is 1, 1, 1. This is 1, 1, 0. See, just now I told these numbers are not following the binary progression. The reason is that when we are moving from left to right or from the top to bottom, then only one place is allowed to change. Okay, suppose you are following the binary progression. Then I will write the binary progression for these numbers. 0, 0, 0, 1, 1, 0 and 1, 1. This is the binary progression what we were doing so far. This is representing 0, this is representing 1 and representing 2 and representing 3. When we move from 0 to the 1 place is getting changed. The 0 became 1. But when we move from 1 to 2, this 1 became 0 and the 0 became 1. Two changes have taken place. Okay, that is not allowed in Karnama. When we move from left to right or top to bottom, only one variable is allowed to change, and that kind of a changing or that kind of a numbering system is known as gray code. Okay, so we are following the gray coding system in that number. Okay, now let us see, since this 0, 0, 0, 1, 1, 1 and 1, 0 are there, and we are having the row coordinator and the column coordinator there, we can number these squares. How? This is representing 0, 0, 0, representing a decimal 0. 0, 0, 1 representing decimal 1. 0, 1, 1, 1 plus 2 representing a decimal 3. Then 0, 1, 0 is representing a decimal number 2. This 1, 0, 0 is representing decimal number 4. 1, 0, 1 is representing decimal number 5, representing decimal number 7. 1, 1, 0 is representing decimal number 6. So see here, because of this gray code, the numbering has become a 0, 1, 3, 2, 4, 5, 7, 6. Okay, this is the way we have to number when we have three variables. Okay, now this Karnama is representing min terms or SOP. As I said in the previous a few minutes before, that this Karnama is going to represent SOP expression. Then all these squares are representing what? Min terms. So min terms 0, 1, 3, 2, 4, 5, 7, 6. Okay. Now, since they are the min terms, variables with a 0 are complementary. We will write it as A bar. And variables with a value 1 are written as it is. Since here they are having 0, 0, they will be written as B bar, Z bar. This is B bar C. This will be BC, because both of them are 1. Variables which are having 1 are written as it is. This is BC bar. Okay. Now, according to the values, we will reduce the expression very soon. Right now, we are listing out those squares, putting the numbers. Okay.